Hello, I'm Simon Pine from Greener Energy Futures, and my organisation helps businesses and public sector organisations tackle energy and carbon reduction. And that requires enormous insights into lots of different buildings and processes. And I can't do that alone. So I rely on partners. And previously, I've introduced other partners that help me with other aspects of energy management. And today, I want to talk with Lawrence Leask of Kaizen Energy about the work that he does and that he's done with me for organizations who have big chiller loads where it's critical to their organization. And with ESOS Phase 4 coming up, a lot of organizations will be faced with the need to audit their energy use. And chillers are going to be a key part in making quick savings. So, Lawrence, if you tell me a little bit about what you do with Kaizen Energy.
Well, thank you, Simon. Basically, I look at heating, ventilation, and air conditioning, and a little bit now of heat recovery. And I try to advise the end user how to improve the efficiency of those systems.
Yes, okay. And I mean, I think, because we've talked before, getting to grips with what are complex engineering systems is not something that many organizations have the in-house expertise to do. They might have, a maintenance contract will make sure that these things function. And we see this with building management systems a lot, where people, well, they're on, so they're working, but actually they're incredibly inefficiently managed. So, somebody like you can really add value when it comes to understanding where the opportunities are. So perhaps for the sake of people who are looking at ESOS and looking at their HVAC systems, what are the top tips that you would have for organizations in trying to make energy reductions?
Okay, I think a really easy win is for anybody that operates a small sort of server room or a comms room.
Yeah.
Check the pipe work. What we find on the pipe work, so the pipe work leaving the building should not be insulated. And we find on servers and crack units, they are insulated.
Okay.
And the insulation can be removed.
Okay. But why do you not want to have insulation on the pipework leaving the building? Is that because you want to disseminate the heat? You want to, get rid of the heat?
Yeah. Well, for a refrigeration system to work,
yes,
the first thing you need to do is lose what we call your discharge superheat.
Okay.
So that's the high end heat leaving the compressor.
Yeah.
And we can't condense until we lose that superheat.
Okay.
Now, for some reason, in the data center industry, they seem to insulate these pipeworks.
Interesting.
I've had different reasons for it.
Yeah.
People have told me it's health and safety, which is rubbish because it's not the sort of place you have people walk around. So, yes, remove the insulation.
Okay.
It's doing no good at all. It's doing more harm than good.
Interesting. So remove the insulation from the exit.
Yes, yeah.
Okay.
Inside the data hall, if the compressor's inside your crack unit,
Yeah.
then by all means the pipe work inside the building needs to be insulated.
Yes.
Because it's not useful to put any heat in the building.
Yeah.
So in refrigeration terms, we use this word useful.
Yeah.
So is it useful? But it's useful to lose as much heat before we start to condense as possible. So that pipe work should be uninsulated.
Okay, got you. But so between the server room and the condenser, you want uninsulated pipes. Is that correct?
Yeah, but if it's inside the building,
Not.
it needs to be insulated.
Okay, got you. Okay, that's interesting.
You don't want heat to introduce heat inside the server room.
No, fair point. Okay, good. All right, that's really helpful. So exit the server room, exit the building before you get to the condenser, have uninsulated pipe runs.
Yeah.
Okay, number one tip. Great. Why is that number one?
It's so easy to do.
Okay.
I literally see it on every single system.
Yeah.
I have written a bulletin for the IOR, which has been published, and the IOR can provide that free to non-members.
Nice.
It's just so simple. The other thing, of course, what it does do also, the reason why it's so important,
Yeah.
is if you've got an old crack system, the condenser's probably getting a bit old. It may be slightly corroded. And so the more heat you can lose before you get to the condenser,
The better.
the more efficient the condenser is going to be. So as we get these high ambient temperatures, you want to lose as much heat as possible.
Yeah.
I've seen 10 or 20 meters of pipe work all insulated outside.
Yeah.
No, you want to remove the insulation.
Interesting. That's contrary to what I would have thought. So that's a really useful tip. Okay, so that's the number one tip. Second tip, then, you think, for managing your HVAC energy efficiency?
Okay. people have heard me speak about this quite a bit, and it's a big issue. If you've got a VRV or a split system,
Yeah.
so or a VRF, they're all the same type of systems.
Yeah.
So these are cooling systems that do heating and cooling. So you might have a little split unit on your office wall or a cassette in the ceiling.
Yeah.
Is look at the insulation externally.
Okay.
What you really want to do is take a little jug of water with you,
Okay.
and see if the insulation holds any water.
Okay.
And look at the quality of insulation. Is there any gaps? Because copper is one of the most effective materials at transferring heat.
Yes.
And if the insulation, which is a rubber nitrile, if that's broken down or they've used non-UV rated, it will start to soak any rain.
Yes.
And there could be nothing worse than having a cold, wet sponge around a copper pipe that's trying to provide heating to your building.
I've seen this. I've seen this so many times. When I walk onto the top of the building where the plant is, and you see these decaying black foam under the pipes, and you can see that they're wet. There's algae around them sometimes.
Yes,
And it's absolutely nuts, isn't it? To put
bonkers.
When you wouldn't get out of getting out of a shower, you wouldn't get out of a shower and put a wet towel around yourself, would you? Because that would just make you cold.
Well, it's actually 1,000 times less efficient to have saturated nitrile around the pipe than having it bare.
Yeah, weird, absolutely weird, isn't it? So number one, server room pipe insulation on the exit of the building before the condenser. Number two, decaying foam nitrile rubber insulation on pipes on roofs, generally on exterior
roofs and side of buildings.
Okay.
I mean, again, because they're on top of buildings, people don't go up there to look at them, and they may just rely on their contractor who's not paying the electricity bill.
Yeah.
So why would he even mention it?
Okay, brilliant. And then, third tip then. Let's give them a third useful tip.
If you can borrow a thermal camera, or you can do this by hand, go around, if you've got an AHU, look at all the flanges, the joints, the manway hatches. These are like inspection hatches. Make sure they're insulated. Make sure that none of these units have got missing insulation, or insulation that's been taken off so somebody can do some work and not been put back properly.
Yeah.
That would be a really good tip, because some of the paybacks for a system could be under 6 months for a jacket or a flange or some decent insulation.
Okay. All right. So we've got you've talked about 3 different kind of insulation issues, and it just shows that you're absolutely scratching the surface here. We haven't talked about good maintenance practices. We haven't talked about cleaning and condenser doors. There's so many rich options to go for. So I want to just leave people those first 3 to have a crack at. You and I will undoubtedly be working on more ESOS energy audits in the coming year for ESOS Phase 4. And I would say to anybody really with significant heating and chilling load on their building, whether a food manufacturer, data center, large commercial office building, that there's going to be some really quick wins here. ESOS doesn't need to be a box ticking exercise. We can genuinely find some insightful, actionable savings very quickly for organizations. Anything you'd like to add?
Yeah, this is a really good tip. This comes from a work that I did with one of my big food companies.
Yeah.
Go around your site.
Yeah.
And record every motor.
Okay.
It's motor rated side, so that's the kilowatts off the side of the plate. Yeah. Look at how that motor. I'm really looking about pumps and fans here.
Yeah.
So you could be air handling units, or pumps for hot water or domestic cold water, building services. Look, record every single pump of a size. Look how that pump or fan motor is controlled.
Yeah.
Is it controlled by an inverter or not? If it's not controlled by an inverter, then you can ask the question, would we benefit from having the inverter control? The really important thing to remember with pumps and fans, if you reduce the speed of a pump or a fan by 20%, you'll half the power consumption, but you only reduce the flow by 20%.
Yeah.
This is the affinity law. If they haven't got an inverter, it's possible. I get people to clamp if they're technically feasible to get somebody to clamp it with a meter to look at the current the motor's pulling.
I'm with you. Yeah.
And then you could work that into kilowatts. Then look at any opportunities to remove belt-driven fans and replace them with direct drive.
Yeah.
That's a really good win, and it saves maintenance. And what I'd say is if you get this checklist,
and
you find you've got 20 or 30 pumps or fans on inverters, is build that checklist up and then go around and do it every month. Because what you'll find is people will go in and switch something from auto to hand.
Yes.
And you'll go back and you'll see a motor working at 50 hertz, which are actually using more energy because you've got the loss of the inverter, as if you didn't have the inverter switched on.
Yeah. I mean, I think what we're seeing here is that if energy is a significant component of your operational costs, and it's going to go up because of the energy crisis, then introducing an expert, and mandated from an ESOS point of view, or if not, just you're concerned about your energy prices, you're an SME that's really being affected by the energy crisis, getting the expert insight from you with me in hand is going to immediately deliver some useful practices for the long term and some actionable savings right there off the bat. Because replacing insulation isn't going to be terribly expensive. Changing controls on things isn't going to be terribly expensive. So thank you. I really appreciate this. What we're going to do off the back of this little video, let's create a little simple content list as well for people a checklist for people to look at these issues, maybe with reference to your website and with reference to some pictures so they can understand what they could be looking for. So that's been a really valuable bit of time with you. Thank you very much. I'm really looking forward to working with you on some more interesting projects next time around.
Yeah.